Good morning, all the students. In today's lecture, let's talk about the structure of the atom. So, we know that the word atom is given by a very famous scientist, and the name of the scientist is John Dalton. So, according to him, the smallest thing or the smallest particle which cannot be further divided is known as atom. In 18th century, or we can say that at the beginning of 18th century, he gave his theory, and this theory is very much famous by the name Dalton's theory of, or Dalton's atomic theory. Okay, so some important points of Dalton's atomic theory are mentioned here. The first point says that the thing which cannot be further divided, or the thing which is extremely small and cannot be destructible, that thing is nothing but the atom. Next point say that when we consider the similar element, or when we consider any particular element, the atoms of that particular elements will be identical, but if we consider the atoms of different elements, they will not have the particular structure. Their structures will be different from element to element, and these atoms always take part in the chemical reaction, and in the chemical reaction of atom, formation of a compound takes place. So these are important points which are from Dalton's atomic theory. Next, whenever we study about the structure of atom, then a very important spectrochemical phenomena which is known as spectra, and these spectra we must know very well. Generally, the spectra is of two types. It can be emission spectra or it can be absorption spectra. Both the spectras are quite different from each other, but the main difference between emission spectra and absorption spectra is the energy. Generally, in emission spectra, the energy is released. The atoms from higher state, they come in ground state after the emission of energy, and in absorption spectra, the energy is absorbed and the atoms go in higher excited state. Both the spectras can be used to study the structure of hydrogen. So whenever the structure of hydrogen is studied, so this is the particular information which we get in the hydrogen spectra. Generally, we observe these important series in the spectra of hydrogen. It can be Lyman series, Balmer series, Paschal series, bracket series, Pfund series, or Humphrey series. And these are the reasons, particular reasons where these series are observed. And here in the next table, these are the ground state values or N1 values regarding each particular series. For example, if we consider Balmer series, then in Balmer series, the region where the Balmer series appears is visible region, and the value or ground state value of Balmer series is 2, and then definitely the excited state value will be more than the ground state value, which can be 3, 4, or any other number which is greater than 2. Same if we see bracket series or Pfund series, over here this is the region, this is the area where the particular series or Pfund series will arise, and this particular number tells us about the ground state value of that particular series. Then next, after this spectra, another scientist came, and the name of that scientist is Bohr. He also gave his very important theory regarding the structure of atom, and according to his theory, or according to the Bohr's atomic model, it is said that whenever we will see the structure of a particular atom, then at the center the nucleus will be present, and the size of that nucleus is very small. Next, the negatively charged particles, which are smaller in size, they are known as electron, and these electrons always keep revolving around the nucleus. So while living, they don't lose the energy. It is because that each electron keeps itself moving in a particular orbit or in a particular path. That is why their energy remains as it is, and they keep revolving continuously in the circle. Next, there are four important quantum numbers, and these four important quantum numbers tell us a very important information about the structure of the atom. The most important quantum number in regarding the structure of the atom is principal quantum number. This quantum number is denoted by the letter n. Then further, with the help of value of n, we can count, or we can find out the number of cells or number of orbits which are present in the particular cell. After principal quantum number, another important number which is known as azimuthal quantum number, and azimuthal quantum number is denoted by the letter L. So for every value of L, we have to subtract 1 from the value of principal quantum number till 0. So if the value of L is 0, then it's clarify that there is s orbital or s subcell, and this, the shape of the particular subcell will be spherical. Next, if the value of azimuthal quantum number is 1, it talks about the p subcell, and the shape of the p subcell is dumbbell shape. So next important number is magnetic quantum number. This magnetic quantum number gives us information about the degenerate orbitals. So number of degenerate orbitals in S subcell is 1, which is given by this particular formula. The number of degenerate orbitals in P subcell is 3. The number of degenerate orbitals in D subcell is 5. Another important quantum number is spin quantum number, and this particular spin quantum number talks about the direction of movement of the electron. It can be moved clockwise or it can move anti-clockwise. After that, here are 4 very important concepts. Okay, so these are the concepts which talks about the nodes. So this is the formula to find out the number of radial nodes. This is the particular formula to find out the number of angular nodes. Further, this is the formula which helps us to find out the number of total nodes. After this, we have another point, and the point is Pauli's exclusion principle. So it states that there will be never in the atom that the sets of our 4 quantum numbers are same. It means all the 4 quantum numbers will always be same in each atom. Next Pauli, there is another principle which is known as of Gauss principle, and it says that the subset of the lowest energy is filled up first. It means Aufbau told about the filling of the electrons, and this filling of the electrons is according to the energy level. And after Aufbau, there is another scientist his name is Hund's principle, and Hund's principle gives us the information about the filling of the electrons or pairing of the electrons. According to him, the pairing of electrons will take only when each orbital will be half filled. So this is something general information about the structure of the atom. In the next lecture again we will study the next important point. So here we will stop. Thank you very much.